We're going to talk about geometric sequences and series. So first, let's just talk about what is a geometric sequence. So this is a sequence where the preceding terms are multiplied by a fixed non-zero real number called the common ratio, R. So I think it's easiest to show you an example. So let's say I have the sequence 1, 2, 4, 8, 16. So check it out. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So in this case, the common ratio would indeed be R. So what if I asked you, if I just gave you like a random sequence and I said determine the A6 and A sub n for the geometric sequence? Okay, so notice I've got 4, 12, 36, and 108. So you probably want to figure this out, right, by taking just what does it take to get from the first term to the second term. So it looks like if I take 12 divided by 4, that will get me to 3. So I'm going to guess that that's my R, and then I can test that out by just multiplying. So what is 12 times 3? 12 times 3 is 36, and then 36 times 3 is 108. So okay, we figured out R. So if I'm now being asked to find A6, okay, then I can kind of just continue this pattern. So my A sub 5 will be found by taking 108 times 3. So this is going to be equal to 324. And so then the sixth term, if I just multiply now 324 times 3, that's going to be 972. So there's my sixth term. And so now we just have to think of how would we define this? So how would we figure out the nth term? And so this is actually something that is captured in this definition here. So the nth term of a geometric sequence can be found by taking the first term times the common ratio R to the n minus 1. So for A sub n, then, in this scenario, the first term was 4, and then we take times 3 to the n minus 1. That would be what this looks like in this context. So this little fact here is a very helpful formula. Okay, so next let's determine R, the common ratio, and then the first term, A sub 1, for the geometric sequence with the second term, A sub 2, equal to negative 18, and A sub 5 equal to 486. So we're going to leverage this concept, but we're going to modify it a little bit for our purposes. So notice I don't know what A sub 1 is, and in fact that's what I'm trying to figure out. So instead I can kind of use the idea here to work with the information I was given. So if I use A sub 5 as my final term, let's pretend for a second that I'm starting with A sub 2. So how many terms are between 2 and 5? So remember, we're going from term 2, so maybe I'll write it out like this. We go from A sub 2, A sub 3, A sub 4, and A sub 5. So the formula here is if this is the number of terms in between, we're going to subtract 1 from that. So if I take 4 minus 1, R to the 4 minus 1, this will give me now a structure to help me at least figure out what R is. So I can plug in the information that I've been given. I've got 486 equals negative 18 times R to the third. Okay, so now let's try to solve this. So 486 divided by negative 18 is negative 27. So I have R cubed equals negative 27. So then I can just take the cube root of each side and I get that R equals negative 3. So now I have found what my common ratio is. And next I can figure out what my first term has to be. So let's go back to the original kind of equation we wanted to work with. So let's use that A sub 2 equals negative 18. I don't know what A sub 1 is, but I know that if this is A sub 2, I can plug in 2 into this formula for n. So this is going to give me then, let's see, let me clear a little space actually. So ultimately, this is going to give me that negative 18 equals negative 3 times a sub 1. And if I divide both sides by -3, I will get that a sub 1 equals 6. And so that's the information that I was looking for. So you can take this idea and then you can kind of shift it around depending on what type of question you're asking. Now, how do we define the sum of the first n terms of a geometric sequence, i.e. a geometric series? So what happens when I sum up the terms of this type of sequence? Well, just like with an arithmetic sequence, we had a series, with an arithmetic series, we had a formula. We also have a formula to help us determine the sum of the terms from a geometric series. So the formula is we take the first term times 1 minus the common ratio to the nth power over 1 minus r. So let's take a look at how this would actually work. So let's say I've got this geometric series here. So I want to sum these terms up, and I'm going from I equals 1 to I equals 8. Okay, so if you're not sure what the common ratio is, you can, of course, always just start by playing with the sequence for a moment and just evaluate some of those terms. So let's see, I have 6, and then let's see, I'll have 2 squared, so that's going to give me 12. And then I'm going to have a sub 3, so it's going to be 3 times 2 cubed, so that's going to be 3 times 8, so that's 24. So if you look, if you're just trying to figure out what is that common ratio, so I start at 6 and then I'm just multiplying by 2. So this part right here, this is what's giving me, right here, this is what's giving me my r, the thing that is being taken to the power. Okay, so now I can use the formula, now that I kind of understand how to find my r in this scenario. I can go ahead and sum this up to the 8th term. So I'm going to use this a sub 1 times 1 minus r to the 8th over 1 minus r. So just a reminder, my a sub 1 is this term here, and then my r is 2. So we figured all that out. So if I wanted to sum this then from 1 to 8, the calculation would be 6 times 1 minus 2 to the 8th over 1 minus 2. And if I work all of that out, so let's see, then I'm going to get that this comes out to 1,530. So there's how you could use that formula to evaluate that sum. Okay, so let's just think about a few other types of problems here. So if we start with 2, and then we use the common ratio 1/2, what happens to the series? So let's just think. So I'm going to start with 2, and my common ratio is 1/2. So I'll take 2 times 1/2, and so let's see, then I'll have plus 2 times 1/2 squared, plus, how about we'll do one more. We're just going to evaluate a couple of these. So 2 times 1/2, can't write, 1/2 to the 3rd. Okay, so what does this actually look like if I evaluate these terms? If I evaluate this, this becomes 2 plus 1 plus 1/2 plus 1/4, so on and so forth. Okay, so let's think about what's actually happening with the sum. Let's like evaluate how the sum looks. As I'm summing those up, if I just take that first term in that sum, the sum of the first term is of course just 1. If I take the sum of the first 2 terms, that was 2 plus 1, that equals 3. Let's keep going. Okay, now if I sum up the first 3 terms of that sum, I have 2 plus 1 plus 1/2, and that's going to equal 3.5. Continue on the pattern. If I sum up the first 4 terms that I had, this is going to be 2 plus 1 plus 1/2 plus 1/4, so we were just looking at this. This equals 3.75. And just to tell you some of the other terms, so if I continue the pattern, sum up the first 5 terms, this will be 3.875. Sum up the first 6 terms, this is 3.9735. So check this out. This is not increasing by a ton, actually. I have 2, 3, 3.5, 3.75, 3.875, 3.9375. This is just very slowly growing a little bit. So what's interesting is as we continue to add on to this, we're adding smaller and smaller fractions, right? I went from 2 to 1 to 1/2 to 1/4. I'll continue on to like 1/8, 1/16, 1/32. So these fractions get smaller and smaller, and we've talked about when the fractions just continue to get smaller, they will eventually get to 0. So what happens with this actual sum then? Eventually, this series will converge. So yeah, this can continue on for forever. If I continue to add up these terms for forever, there will come a point where when I've added up enough terms, the sum is just always going to equal 4. It's going to be either very close to 4 or exactly 4. So just the closer and the more and more terms that you add in this series, the closer it gets to 4. That's kind of crazy if you think about it, actually. I'm adding up an infinite amount of things, and eventually it can never get more than 4. That is crazy, like from an infinite level, right? So the fact that this series eventually converges has a formula actually associated with it, and it looks like this. When we're going to an infinite amount of terms, we can calculate it like this. So if I were to actually run out this calculation, this will give me 2 divided by 1/2, which does indeed equal 4. So this formula is actually what's known for an infinite geometric series. If I want to add up an infinite amount of terms in a geometric series, they will converge to this sum right here. So remember that a sub 1 is the first term and the r is the common ratio. So let's take a look at how to actually evaluate some of these infinite terms or infinite series. Okay, so let's say that the first term is 1 and the common ratio is 1/2. Okay, so this is assumed to be an infinite series, so I'm going to just use this formula. The first term is 1 and the common ratio is 1/2, so that's how I'm going to enter in that information. So this comes out to 1 over 1/2. So just to remind you of the math, that's 1 divided by 1/2, so that's going to be 1 times just 2. So if I'm adding up an infinite amount of terms, my first term is 1 and the common ratio is 1/2, this series is eventually just going to go to 2. That's what all of the terms, the infinite amount of terms added up together, will eventually equal and converge to. Okay, so what about this next series? So this is another infinite series because I'm going from I to infinity. So I've got all this information here. So if you're not sure what the first term is, I always say just like plug in I equals 1. So let's figure out just what is the first term in this series. So if I plug this all in, here's what this looks like. So this becomes negative 1/2 times negative 3 over 4 to the 0. Anything to the 0 power is just equal to 1. So this is negative 1/2 times 1. So the first term in this series is negative 1/2. And then remember, the common ratio is going to be the number that has the exponent attached to it. So in this case, this part right here, this is my r. So then I can use my formula. So this will be negative 1/2 over 1 minus negative 3/4. And this equals negative 2/7. So if we were to continue to add all these terms in this series for forever, this would eventually converge to negative 2/7. Okay. So let's do this one more time. So again, if you're not sure of like how to find the first term, you can always just calculate it. So what I would recommend that you do is you find the first term here and then you try this on your own and hit play when you're ready. So in this case, the first term is just 3/7, and that's also the common ratio. So this is going to be 3 over 7 over 1 minus 3 over 7. And that ultimately equals 0.75. So adding up all of these terms on an infinite basis will eventually just get us to 0.75. Okay, so that's just like a really brief intro to geometric sequences and series. So I'm just going to leave it at that, and I'll see you guys in the next video.